All right, so let's talk about how things are similar to each other. We've talked about in the past about being congruent from one figure to another, meaning that they're the same. And these particular examples that I want you guys to go through is I want you to see whether or not they're similar. So that means, is one half the size of the other? And we're going to use proportions to try to figure that out. So the first thing that we would do is kind of look at and compare our figures. So with this particular one, you see that this 4 is going to be corresponding to that 6 because we flipped the triangles. So if we do 4 over 6, that should equal another ratio. So we'll do 8 to 12. So to check to see whether or not these are actually congruent is we do the 4 times 12, you get 48. And then you look at 6 times 8, right, and you get 48. So as long as those numbers match up once you've cross-multiplied, then you're all set. And then as you're kind of looking at comparing the area, without even calculating the area, you can take one of your two fractions, whether 4 over 6 or 8 over 12, and reduce that down to tell me what the area would be compared to the to each one. So like here, this would be 2/3. In question number 2, they give you a rectangle. They give you a width of 3 and then a length of 6. And it says apply a size transformation of magnitude 4 to the following rectangle. So what that means is you're taking each side and multiplying it by 4. So how long are the new sides? Well, 3 times 4 would give us 12, and 6 times 4 would give us 24. When they're asking us to figure out what the scale factor is, how much larger is the other one, what you do is you can take the 3 and the 12 and make a fraction. From there, we would just reduce, and that becomes 1/4 because I divided top and bottom by 3. Okay, so let's move on to the next page. Okay. Then it says, apply a size transformation of magnitude of 1/3 to that triangle. So again, that triangle is 3 and 6. Okay. So if we were to take 1/3 of it, that would mean we divide each side by 3. So you would end up getting a 2 and a 1. Okay. So if we were to compare the two, you've got the sides that'll be 1 and 2. And if we take the 1, we compare that to the side that's 3, you would end up having 1 to 3. So it'll be 1/3 the size. Okay. So let's continue on. So question 4, it says quadrilateral RST is similar to LMO. Okay, so we've got RSTV and then LMNO. RST, so that we've got 6, we'll say 10, 12, 14. I know that doesn't look like the figure, but just bear with me. And they say that the shortest side, so we're going to say this top side, is 9. The scale factors comparing two sides. So we know this top side, we know the top side of this one, so it's 6 to 9, or we write 2 to 3. Okay. Then we have to find the perimeter, of each one. So the perimeter of this top triangle, we're going to add up all the sides, so 6 and 10 is 16, and you've got 12 and 14. Add that together, and we get 42. Then we would want to say, well, if it's a 2/3 ratio, what you do is you take 2 over 3, and we're going to set that equal to 42 over x. So now we cross multiply. So you're going to go 3 times 42. So that ends up being 126. So we're doing that. And then 2 times x. and 2x. Divide each side by 2. And x equals 63. So the perimeter of the second one is 63. So no matter what we look at, we end up getting a ratio of 2 to 3. The area is going to be the same, 2 to 3. Then we've got some examples of where we're just trying to figure out, are these similar? So again, we're going to take and figure out that 3 corresponds to the 12, so we have 3 over 12. We're going to set that equal to 4 over 15. So look at how I set these up. If I start with this first triangle, then the second fraction will also start with that triangle. Okay. So now we just do 12 times 4, which is 48, and 3 times 15 is 45. So if these two numbers don't equal each other, then we say not similar. Next one, okay, so you've got the top, or the bottom of this one, bottom and base of that one, so 8 over 10. Then I'm going to take 12 and put that over 15. Okay. So then we've got 12 times 10, that's 120. And then 15 times 8 is also 120. So we say B is a yes. Next one, they're saying, well, these are similar to each other, so we need to create a ratio. So it's a 1/3 pattern. So you have 1/3 equals 2 over x. Again, look at how I've set up my fractions. Then we cross multiply. So you've got 3 times 2 is 6. 1 times x is 1x. So x is equal to 6. Next one. So we're going to do 5 over 2. Now, does it matter if I put 2 on the top and 5 on the bottom? No, it doesn't. I just did this because this particular triangle was first, and then I just set up my fraction that way. And then we do x plus 6 over x. Oops. Then we're going to cross multiply. So this one's going to take a little bit more work to do, but we can still do it. So we're going to do 5 times x. So we have 5x equals 2 times x plus 6. I'm going to distribute the 2 with the x and the 6. And we get 5x equals 2x plus 12. Then I'm going to subtract 2x from each side. Get 3x equals 12. Divide each side by 3, and then x equals 4. We can go over some more of those next time. This one, okay, so they're saying this is similar. So this statement here says there's some type of ratio, that one's a third of a size or one's a half a size. So what we do is we look for the sides that we do have, okay? And we set up a ratio. And what I'm going to do is I'm just going to simplify this. So that way they're smaller numbers. So 12 divided by 4 is 3. And 16 divided by 4 is 4. So now I've got 3/4, which is smaller, and I like that better. Then we're going to solve for x and y. So I'm going to do y first. And that corresponds to 9. So if we started with 12 before, I got to start with 9 again. And I write that over y. Cross multiply. So you'll have 3y equals 9 times 4. So 3y equals 36. Divide each side by 3. And y is 18. Then we set up another one. And we'll do again, we can start with that 3/4 or 12 over 16, it doesn't matter because they're both the same fraction. And then we do the x and the 8. So x is on top this time and 8 is on the bottom. Just because the 3 corresponds with that 12 that we originally had. cross multiply. So you got 3 times 8 equals 4 times x. So you've got 24 equals 4x. Divide each side by 4, so x is equal to 6. Okay. So these are just some examples. I want you to go through and do as many as you possibly can, and then we'll talk about it more next time.